I'll go to the one on the 19th. I definitely will be there.
This is surface winds, but like you can see where they're all spinning. Yeah, it's just
Are you talking about 19th? Convergence of the surface makes it go. Yeah,
they oftentimes
convergence of the surface.
All right, thanks, Pete. Okay, we're going to get started. Thanks for coming to our weekly weather discussion. Incidentally, anybody else who ever wants to do this, you're more than welcome. And we're training a bunch of people in 452 right now who could certainly step up and do this. There's no doubt about that. We've been having some really fine discussions in class. So it takes some time to prepare, but I encourage you to consider it. And I'll say consider it strongly because it's a good exercise. What a week it's been. Everywhere it's been interesting. Pacific Basin, Atlantic Basin in the Northern Hemisphere. Here's a movie of the Pacific Basin. Let's just watch a couple of things. First of all, obvious separation between polar air and tropical air. Watch this little excursion at about the dateline. On its eastern edge, it develops a little wave, and then that wave forces a little bit of a plume of moisture all the way north of the islands. Really nice. A nice interaction between extratropical disturbances migrating southward to well north of the ITCZ, but they don't have to get down there. They just have to get somewhere where they can generate a circulation that kind of tugs on the ITCZ, and then there's these poleward transports of moisture. This one, since it's early in the season, doesn't go very far. It gets all the way to the west coast, and it's kind of part of this high cloudiness. Not that patch, the next one. But later on in the season, when the waves can make their way even further south, and with a little bit more frequency and regularity at more than one longitude, then you start to see a series of these poleward moisture plumes, and things get pretty interesting. So there's the one that kind of came up, and it's on its way to the British Columbia coast. Even more interesting this week was the Atlantic Basin, which we have to talk about. Probably not with the long movie because it's just going to take too much time. But I've got a few things I want to show you about that. Okay, so thanks for this overview, Pete. This was interesting. Even though it's not the most interesting basin this week. So, when you get to pick from two interesting basins, that's pretty good. Not so much over the continent, but that's for the forecast. There'll be plenty to talk about with respect to the forecast over the continent. So can we go, Pete? Yeah, let's go here to the Tacoma Narrows Bridge. Today is the 85th anniversary of this interesting event. And it's worthy at the front of the discussion here to just listen to this. This is great.
A few months ago was built at a cost of over $6 million. But misfortune overtakes the great structure. These are some of the most amazing pictures ever recorded by a newsreel. The actual collapse of the world's third largest suspension bridge.
Notice the trees in the background. It's howling in the Tacoma Narrows. Yeah, and gusts well over 60. Look and see the trees.
Only a 35-mile-an-hour wind is blowing, but this apparently sets up a rhythmic swinging of the bridge, which increases with each swing.
Yeah.
Finally, the swinging road and the suspension cables give way and plunge into the water below. Fortunately, the only casualties were a car stalled on the bridge and a dog.
So this was an intense cyclone. I think the sea level pressure in the Tacoma Narrows storm was something in the 970s or something like that. But the topography in the Puget Sound is such that if it's in the right place, you can get just a howling wind through some of these gaps. And this is a couple thousand feet on one side, probably similar somewhere else, maybe 1,500 feet. And it was enough to create a steady wind that absolutely resonated with the natural frequency of the bridge, and that was the end. It just got swinging, and the swinging, as resonance does, gets worse and worse, and the thing went down. I want to show you some 500 millibar maps that will lead to the extraordinary event that occurred, the first of the two extraordinary events that occurred over the Avalon Peninsula on Newfoundland this week. So let's go to the 500 millibar maps, Pete. I know this is a little bit different than usual, but it's worth it. And we'll do a movie, yeah. And we'll just go right to the beginning of the movie. And We don't need to take all these days, so maybe we go all the way to Sunday. But you can already see lurking, and we made mention of this last week, very intense baroclinic zone, and it showed the same thing we saw in the satellite picture. To the north of that baroclinic zone, open cellular convection prevailed over a wide swath of the Gulf of Alaska and westward, and then everywhere south of it where it's very warm, nothing. And you could see that dramatically. So watch that baroclinic zone come across southern British Columbia. Here is now we're at 12Z on Saturday, still maintains a pretty intense, strong intensity into now Alberta. And then it's more intense along the Washington coast. And here it is really intensely in the southern prairie provinces, entering the southern prairie provinces and stretching out over the ocean. This is now Sunday morning. And here's a really good time to look at it. Because even at this time, you can see there's geostrophic cold advection over North Dakota and extraordinary cyclonic shear. The winds to the south are in the 85 to 90 knot range, and the ones near Lake Winnipeg are at 35. So there's really strong cyclonic shear and cold advection. Another way to look at that is thermal wind is a proxy. The isotherms can be a proxy for the thermal wind, and there's a vorticity max right here. So everywhere in this region, there's NVA by the thermal wind. There's subsidence on the warm side of this baroclinic zone, and it generates tilting of the isotropes and the development of an upper front. All of this is happening while the citizens of Newfoundland are just kind of wondering what's going to happen at 53 degrees north this week. There's no obvious connection yet. And then there's this funny little trophiness down over the southeast states that's intense but very small in its meridional and zonal wavelength. So it's not going to be the main feature, although there's some sensible weather associated with it. Not what I want to talk about. So let's go ahead again, Pete. This is 12Z Monday. What the hell happened? So these are every 5 degrees, extraordinary temperature contrast across all the way from Lake Michigan back to north central Montana, Glacier National Park. So this is a really dramatic upper front. We won't cut the cross-section through it now, we'll do it at a later time, but it's going to have some of the signatures that you might expect with that folded over tropopause, a strong jet core. You can already see the winds at Minneapolis, 115 knots. There was nothing in the 100-knot range at the 12 hours prior to this. So we're tilting horizontal vorticity into the vertical, and that speeds the wind up, and you get a really intense baroclinic zone. Not only that, but here it's only 55 knots at International Falls and 100 at Minneapolis. Extraordinary horizontal shear. And so there's a large vortex structure associated with this thing as well. And that helps for reasons that are hard to quickly diagnose, but that helps to carve out trophiness at the end of this upper level frontal zone. So you start to see the trophiness develop right around the eastern shore of Lake Michigan at this time. This was Monday morning. I think we had a pretty nice Sunday, if I recall, didn't we? Pretty nice day. So all of this stuff happens unseen. You don't notice it if you're at the ground because it's all kind of stealthy, but it doesn't remain that way. So let's go ahead a little bit, Pete. This is 0Z on the 4th, Tuesday. Look at how sharp that contrast is. It's minus 30 in southwest Quebec, and it's 13 at, whatever that is, Gaylord, Michigan, and 11, I think, minus 11 at Green Bay. So an extraordinary temperature contrast. Several locations have winds well over 100 knots. Green Bay was right at 100. In the Upper Peninsula, it was 120, and then a couple other hundreds floating around. And then extremely sharp curvature right about over the Hudson River. So you go straight across New York State, and then suddenly you're going almost straight from the south over New Hampshire and Vermont along the Connecticut River. So very sharp curvature there. And the building of, and the proximity, I should say, maybe not a building yet, but the proximity of a reasonable downstream ridge. I'd like that to be closer if you really want to get things going, but nonetheless, there it is. And this is the beginning of a time I'll show you on Viz 5D. The next thing, though, I want to show you is what happens when you have this kind of geopotential height gradient, so strong geostrophic wind, and then the sudden emergence of this kind of curvature. Let's go to 300 millibars, you can see. We'll do the movie there. Oh, wait, Pete, before we do that, I'll give you a little preview. Go one step ahead. Woo, look at this. 20 degrees. And extraordinary curvature just to the southeast of Nova Scotia. Here's the Avalon Peninsula, and that's going to really take the brunt of it. But you can see there's going to be a lot of stuff going on here. And we'll show it in some more detail in a minute. So let's go to 300 millibars, do the same thing, please. And we'll start on like Monday, I think, probably good enough. Right there, perfect. So here we have the strong jet, reflective of the underlying strong baroclinicity. Maybe click ahead one more time to 12Z on Monday. And that jet is gotten more intense. These are 189 knot winds in this white strip right here. It's not a stubby, it is a stubby jet streak. There's a really rapid decrease in the wind speed from 150 plus to 75 over a short distance. So the deceleration or the long flow speed change produces a substantial amount of upper divergence, and that's cooling the column and beginning to cut out this trough, which wasn't there at the prior time. Let's go one more time. And it continues because the jet streak abruptly ends, producing strong upper divergence, further cooling, deepening the upper trough. And so that's what we have at 0Z on Tuesday. Now watch this. Before we go, 167 knots, and then this other one is in the 130 range, but it hasn't yet gotten to the curvature in the trough. Watch the next time. What happened to the wind speeds? So this is only in the first white, it's in between 90 and 100, or 110 knots. So we went from something in the 130 to 150 range to 110, or 90 to 110. Why? It's not because the wind speeds completely disappeared or the geopotential height gradients weakened. It's just there's a lot of counterflow in the ageostrophic wind. So you can't get an exact measure of that, but to see winds in the 130 knot range suddenly decrease to something in the 100 knot range right when they encounter the curvature, that means you've got 30 meter per second ageostrophic winds, likely going the other way. Not in the straight flow region over, over Newfoundland itself, so you have extraordinary upper divergence in the ageostrophic wind there. This is about the time this thing really starts to explode. And I can barely contain my excitement to tell you. But I'll just tell you the stats first. At 0Z on Tuesday, so 12 hours before this, there was a minimum in sea level pressure over the sort of the middle Atlantic states at about 1,008 millibars. 24 hours later, there's a cyclone 942 over the Avalon Peninsula. 66 millibars of deepening in 24 hours. I think it's close to a world record for an extratropical cyclone, but absolutely remarkable. And part of that's fueled by the just absolute retreat of air aloft in that vicinity. It just disappeared because it was going in the other direction, and so you had this huge divergence aloft, mass flux in the column, taking the air out, the pressure drops. So let's take a look at this evolution from the perspective of Vis 5D, if we could, Pete. And I'll do it as quickly as I can. So here's the initial condition, Monday 12Z, so a little bit upstream in time from what we were just looking at. But in purple is the 500 millibar potential temperature. And so here's the strong upper front with a little bit of curvature over the state of Michigan and Lake Huron that we were just talking about at that time. And then let's click ahead one or two times. These go every 6 hours. So 18 hours at 18Z on Monday, that upper front has kind of made its way to Lake Erie.
Every 3 hours.
Oh, every 3, okay. So we did a 6 hour. We'll do another one. Let's do every 6 hour increments. And then right over Long Island is sort of the terminus of this upper front. Look at that extraordinary baroclinic zone. Exactly from Lake Winnipeg across all the lakes. I wonder how many thousands of times that's happened since the glaciers retreated. Probably many, many thousands. But this one, really dramatic one. Here is the Avalon Peninsula in Newfoundland. And St. John's, Newfoundland is right up here. Cape Race is down here. That would be the place I'd really want to get obs, but I don't have it. But I have them from St. John, which actually is a little bit sheltered compared to Cape Race. But it won't matter. When you see the numbers, you just won't believe it. Okay, that's 0Z Tuesday. Let's click ahead twice more. This is now 6Z on Tuesday. There's your upper front. Why don't we put 500 millibar vorticity on there too, Pete? These are contoured every 4 units. Let me take the theta off because they're kind of sitting on top of each other. You can kind of see it better just for the time being. Every 4 units times 10 to the minus 5, beginning at 16. So this is 1.6 times F. And then in the middle here, right off of Martha's Vineyard and Nantucket, you're in the something like, 3 times the Coriolis parameter right there. Importantly, a really strong gradient right on this front edge, just southeast of Nova Scotia. Put the theta back on as a proxy for the thermal wind. Extraordinary PVA by the thermal wind going on right here over Halifax and the Bay of Fundy at this time. Just for the fun of it, Pete, what's the sea level pressure look like? And then take everything else off. Pretty wimpy, right? This is the 1,012, 840, just below 1,000 millibars right here at 06Z on Tuesday. But it's beginning to take shape. Click one time ahead, Pete. This is just 3 hours later, and we're already 8 or so millibars lower. So let's go to 12Z on Tuesday. And here again, here's the point of contact, really point of contact. This storm is not as intense in the modified version of the GFS that comes into Viz 5D. It gets a little smooth compared to what you actually had in some of the model output. But that's 1,012, 1, 2, 3, 4, 5, 6, 7, 28 millibars less than that's 984 right now. And put the theta back on. And we've got the same thing. It's right at the end of the upper front, and put the vorticity on there. And of course, that's because the cyclone center is right underneath the region of extraordinary PV. It's even stronger at this time. So the whole wave, both at the ground, is responding to the development aloft. And the development aloft here is extraordinary. And it just keeps on going. And you can maybe we can just click to the sea level pressure and take everything else off for the time being. A couple more clicks. One more. And then that's 984. This is 12 millibars lower than that. 972. One more. Gets even worse. That's 980. Now we're at 968, just as we're starting to make landfall at Newfoundland. And as I say, this is not the actual raw data from the GFS. It's a little smoothed, and so the values are smaller. It doesn't get as low in this depiction of it as it actually does in the raw model output. So let's go back to 06Z on Tuesday. I think that's when I have my cross section drawn. Right there. Let's try. Where's theta? And then I guess put the horizontal on. I can check. Yeah, that's where I wanted it. Okay, so we can take all that stuff off. Let's take a look at what theta looks like in the vertical here, right through the terminus of the upper front. That's a pretty nice upper front, isn't it? Look at that. That's every 3 degrees Kelvin. So there's 1, 2, 3, 4, 5, 6, 7. That's 18 degrees horizontal temperature contrast right through that thing at approximately 600 millibars, and it hangs down from the tropopause, and there's no surface manifestation along this cross section. Let's see what the PV looks like at this time. Oh yeah, that's pretty nice, isn't it? So this is every 1 unit starting at 1, and if you put the theta back on, oh yeah, you can't really, can you? Okay, but we go down all the way to the base of this upper front, and that's probably at about 800 millibars in this case. And then if we take theta off again, Pete, look at this wall of PV with a little bit of an exception here. This is effectively a wall that goes right up to the tropical tropopause, and you've got an extraordinary boundary right in that location. And then we want to know what might be driving this development. Let's take a look at vertical motions. Oh, how do you like that? I'm showing only the negative vertical motions, so this is all subsidence, and it's just what you might expect. It's right underneath. The jet core, of course, will be right here. Here's the subsidence under the jet. Put theta back on. And of course, it's acting to tilt the isentropes in the upper troposphere, and it's dragging the PV down along those sloping isentropes. And the high PV is the mechanism by which you get this strip of extraordinary 500 millibar vorticity. That's what it is. And so that thing is what drives the development at sea level. Just classic. And until 1955, we didn't have a hint of this. That's only 70 years ago. Isn't that amazing? Just amazing. Okay, so that's connection between extreme development and predecessor upper level frontal development is well established in cases like this. So the last thing I want to talk about.
Sorry, Jeff.
Yeah, sorry.
I forget, what time is this in the evolution of the cyclone? Is it already at its max?
It's not at its maximum.
Okay.
No, it's just begun the 0Z 4th of November to 0Z 5th of November development of 66 millibars. It's only 6 hours into that.
Okay, so I'm curious what the PV looks like later. Do we get a tower that
yeah,
emerges?
we can do that. We can go ahead. And this will be, I might have even done that already because I have other PV and theta. I forget what times though. So let's put the sea level pressure back on. That'll be a guide. And then let's put those cross sections on too, Pete. These here, just theta prime for now, because I just need to know where it is. Let's click through. It might be there. I can't remember if that's it or not. And then let's put the PV on there as well. This one here, sorry. And then let's flip it up and see where we are. Now we're about halfway through the extreme development. And yeah, see, look at, here's the PV coming all the way down to the ground. And look at how this is really interesting too, is that there's a little warm bubble right here. It's got a warm core up to, I don't know, 800 millibars or something like that. And so it retains the same wall structure, but now this is extra. And so that's like putting I don't know, some sort of giant hydraulic drill and spinning it cyclonically. And then the air can't do anything but do the same thing, and you get this extraordinary development there. That is warm core, a little bit anyway. And it had no tropical origin. This one didn't.
It wished it did, though.
Huh?
It wished it did.
And I wished it did too, for your sake. I'd feel so much better if it had. But it didn't, so it's just the way it is.
It would have been even more dramatic. That's all.
Yeah, that's right, that's right. It did have, this is only anecdotal, it seemed like, no, it's the second one that did that. I won't say this on this one. Okay, so there's, and let's just put the PV itself on there. I think I've got that saved as well. Yeah, I just hit OK, it should be. Yeah, so there's your column right there underneath, and if you flip it around, you can kind of see what's going on, so.
I'm going to imagine that the lower piece that's...
There's the upper
detached-
front, right there.
Yeah, the part that's detached from the main dynamical tropopause, I'm imagining that lower piece is probably due to an air sea interaction.
That's probably right, yeah. So it's diabatic and it's kind of it's sequestered inside there. Yeah, that's probably right. So this is just an amazing event. And you'd think, okay, if you live in St. John's, you get one of these a year, maybe two. They got 2 in 1 week, and we'll talk about that.
Can we go one more step forward? Sorry, back
Yeah.
to the cross-section. Just curious at how it grew, that piece in the lower troposphere grew.
Right there.
Or just the isosurface as well.
Yeah, that's what we're looking at here. So
So tilting it down so we can see the...
it's connected a little bit, but it hasn't always been, as you pointed out, as we saw at the prior time. So that's like the finger of God saying, I think it's going to be windy in Newfoundland today. Pretty exciting. And how it gets there is really interesting, of course.
Yes.
So it's a great storm. We can't say more about it right now, but it's just another of these, they're, like Michael says, and he says it in this disparaging way, they're a dime a dozen. That's what makes it so fun. You don't have to wait long to find another good one. In the tropics, you might get 3 every year. We don't want to make them special. Yeah, that's what makes them special, but also, please. Okay, and then, so one last thing I want to say is, we can get out of this 5E. This was not the the only storm of that region this week. So if we go back to the 500 millibare loop, it might still become there. Let's end it at 0Z on the 4th, because this is when our big storm, first storm number 1, is going crazy over St. John's. I'll show you some obs from St. John's too on the 4th of November. You'll like that. But then here comes a northwesterly. Let's go back a couple times. Here comes a northwesterly flow event with a modest, if only modest, temperature contrast. One more click ahead. Looks a little less, a little more intense over the Dakotas and maybe stretching up past to the west of Lake Winnipeg. Here's a little bit of a trough developing. Let's see what happens the next time. Much sharper trough, in more robust baroclinicity. Nothing like the first one, but still pretty robust. And we're getting into November 6th. Let's see what happens next. Look at that. Sharp upper trough, reasonable baroclinicity. One more time. And we've got another upper low sitting right over the Avalon Peninsula. What does it look like at 850, I wonder? And we'll look just at the second storm this time. So here we go. There's not much, let's go back a little bit. Not much going on at 850. There was a little prior lee-side troughiness, a little warm bubble right with this thing. Let's keep going. And then it's slid across the lakes. You don't see much development. Kind of, again, weak development by this time, 0Z on the 6th. And then the upper wave is matured, and this thing really starts to go to town over Nova Scotia. Watch what happens at the next time. Really robust feature right over the Avalon Peninsula in Newfoundland. They got down to 968 or something like that. I think there was 32 millibars of deepening in 24 hours. But it's the back-to-back nature of this, of getting battered by these things that's interesting. So let's take a look at the obs from St. John, Newfoundland. And this is hourly data. You can slide up the page. They report station pressure in kilopascals. So 99.8 is 998 hectopascals. So let's watch what happens here. And then the wind speed is in this column. So we're going to have to watch that. Sea level pressure early in the day, of course, not that low. And then it starts to really go down. You're into the even more so. We'll watch the wind speed right in this column. Keep going. Look at these winds. All of a sudden, 40 knots. We're at 984. 68 knots, we're at 964. That's only, what is that, 4 hours? So there's migration as well as deepening, but that's 20 millibars. And then a 72 mile per hour wind just 3 hours later, and we're at 952. And keep on going, 69, 55, 77 at midnight local time, or Greenwich time, sorry, 936. So this thing is just going crazy. Look how many hours in a row you had wind speeds mostly in the 60s and 70s, occasionally some respite, but amazing. And you would go to the next day and see the same thing. And then if we go to the 6th, which would be the last day of the record, and also the day that corresponds to the second storm, paying attention just to the wind speeds, 64, 51, 43. So we're in intense wind speeds, again, with the approach of that second storm. And sea level pressures at St. John down in the low 970s by the time it's all over, or mid-high 970s by the time it's all over. So back to back, and then slide down one more thing, Pete. Oh, moderate snow at a couple of these times. With winds in the almost 40-knot range, snow and fog, that means you can't see anything. It's 956 with a 39-knot
Those are
wind.
kilometers per hour.
They are?
Yeah.
Oh, I didn't notice that, sorry. Okay, so a little exaggerated. So cut them in half.
Real winds.
Yeah, yeah. Well, yeah. So anyway, very impressive back-to-back events up on the coast, and so that's pretty neat, I thought. I didn't bring the cold pool. We're still 9th warmest, September 1 now to November 6th, so it's stayed exactly where it was last week. So I'll bring it in next week again. So thanks, Pete, for showing all that stuff, and turn it over to you, Michael. We'll give you this.
Second. If we could bring it, yep, please. If we could bring up that first, the file is just Weather Watch info. First of all, I'd like to thank Nick Bostad, who sent this to me just the other day. This is some information about Hurricane Melissa. Even though we just had a great discussion about extratropical cyclone, wanted to just go back and see some really interesting. It may take a moment to come up. Just a couple dropsons from Melissa that were really pretty impressive. Oh, okay. So we're not going to be able to look at them today. Can you look at a JPEG or can we convert it? This will take just a moment. Else we can look at this next week. Okay. If you could open up the next one though, the GSF. Okay, so this is, all right. Okay, well, we might.
I can make that happen.
Okay, while that's happening, the big weather story that we're going to be dealing with coming up for this weekend is the extreme cold that's going to be entering the U.S. probably in the next 48 hours or so, with temperatures in some places they're going to challenge record lows that go all the way back. So this is from Nick Bostad. This is a couple of dropsons that were done in Melissa a few days before landfall. And they recorded some of the strongest winds ever recorded, in the range of the strongest winds ever recorded by sort of dropsons. And also some weird things in the temperature dew point profiles that I haven't had really a chance to interrogate. So this is the level of the dropson. It says surface 930. This is when the cyclone was very much more intense than 930 hectopascals in its intensity. And we kind of know that this wasn't the center because we have winds that are still 141 knots. So this is in the southern part of the eye wall when the drop was done. But you can sort of see the temperature structure, basically saturated, really saturated in the eye wall. Really strong winds. If you go to the later one, these are, go to the next sounding that was shown. Now this is bizarre with the temperature actually lower than the dew point. That's a failure there. But look at these winds. 219 knots, 214 knots. So if you want to see really strong winds, John, tropical cyclones are the way to get that. Another interesting aspect of the storm. So I think these are the top, Nick was saying this was in the second to fifth strongest winds recorded from in a dropson ever. And they obviously have to go through quality control, et cetera, but this is really impressive wind structure with this particular event. If we scroll down just a little bit further, also from the so-called advanced VORAC technique, which I'm by no means an expert at all in, but this is using satellite imagery to infer the intensity of a storm. This is particularly useful in places where they don't do hurricane reconnaissance. Its estimate for intensity at this particular time was one of the highest, I guess, recorded, 871.5 hectopascal with winds of 185 knots. I think the reconnaissance didn't quite match this. It was an impressive storm. It was like in the 890s, low 890s at the time, just before landfall. So that was really impressive with the storm. The next image that I wanted to show, well, there's an image here, but there's also one more file to open up, Pete. This is just a sort of brightness temperature, prior to landfall. I thought was really neat. This was showing from the GOES, or the Geostationary Lightning Mapper, the GLM. This shows the lightning flash rate, as well as the estimated central pressure of the cyclone before landfall. Recall landfall was on between the 20th and 29th. And just the extreme number of flashes, with those 699 flashes per minute during this, just prior to landfall. And it was associated also with this period of just enhanced deepening just before landfall. So that's just really incredible. I think this is a record-setting flash rate, I think, for this particular type of detector. I don't know if anyone from SIMS wants to sort of comment on that, but doesn't appear, again, this is just by eye. Often people will talk about increasing flash rates are going to be associated with deepening, with extensive deepenings, but it's hard to say. I guess maybe this is just because it's so intense. But I mean, you do see some little blips here, but it's not everywhere that you see it before you begin to get some deepening. But to the extent there's a correspondence there, this is certainly a great example of that. It's a really intense flash rates, which is something that's often with tropical cyclones, I think when they're in sort of steady state, the flash rates are relatively low, but I guess when they're undergoing either rapid weakening or rapid intensification in particular, with very vigorous updrafts, you're going to probably get this occur. So just really another amazing aspect of this particular storm.
I'm struggling to have a reasonable concept of why there should be a relationship there. Is it just this unsteady vertical motion?
I think it's charge separation. So with vigorous
vertical motions, is that what I'm?
and vigorous updraft.
It is, yeah.
Yeah, okay.
So it's
this testifies to that kind of convective activity.
Right.
It's not steady state convection.
Updrafts and downdrafts.
Yeah.
In.
Right.
Okay.
Right. So you get the charge separation, then that'll lead to the lightning occurring. But these rapid, very vigorous updrafts. But often you'll see in just tropical convection, I don't think lightning is a big factor typically. Right? I mean, if they're all warm clouds, obviously there's no ice, you're probably not going to get much. But this just goes into the intensity, the vigor of the convection and the cyclone, and you get these what are so-called convective hot towers, which can lead to, with extreme rapid upward motion, you can get lots of convergence near the surface, spin-up vorticity that could feed into the overall vortex as it's intensifying.
Yeah, I don't know if this is a plotting artifact, but when you go from early in the day on the 27th of October almost to the 29th, there's no white spots along that axis, so there's no times where you don't have
Very
flash.
vigorous convection, right?
So you have continuous flash.
That's a good point.
Not just rapid rate at one moment.
Right.
So that's maybe related to the same thing.
No, that's a
But
good.
if you looked at the overshooting tops, there was the eye wall, and then there was actually very vigorous deep convection kind of outside
Oh, is that
the eye wall, and I think a
Right.
lot of that.
Was-
So it wouldn't be necessarily continuous lightning in the vicinity of the eye wall.
In the eye,
It would
just
be out.
Could be outside, right?
Yeah.
But each of those
Really?
convective turrets, even outside of the eye wall, are generating vorticity that eventually will come into the vortex and get vorticity, potential vorticity gets sucked into it. So that's kind of a neat aspect of that. So out of the tropics, I'm not going to say this is the last time we talk about a tropical cyclone in the Atlantic this season, because actually in the GFS at least, if you want to believe, 384 hours, I know that's extreme, there is another cyclone to be dealt with, this time in the Gulf of Mexico. But we're going to not talk about that today. We're going to talk about mid-latitudes. And beyond the cold, the possibility of a little bit of actual snow, accumulating snow. So let's first go to Kai, please. And start with my favorite. We'll go to the meteorogram the first time because
We had a discussion yesterday for nurture where more than once, Andrea can back me up, the word meteogram was used
and it's wrong. But
without any comment. I wish you'd been there.
oh yeah, that would have been comments. I'll tell you that. This is a meteorogram, folks. And anyways, we see the decrease. Here's our temperature trend today being relatively warm, getting into the 50s. And then we can see for Saturday staying actually in the 30s, so the forecast. And then by the time we get to Sunday, maybe we'll stay in the 20s, or certainly below freezing. So cold weather's coming. But again, the forecast, as we'll see in the evolution of it, is for the potential for records that go all the way back to the 1800s to be broken for low temperatures. This is going to be a fairly extensive cold air outbreak for the eastern half of the United States. So not necessarily for us for record-setting temperatures. And for precip, we do have a little bit of precip. Models have been variable about this. We'll look at this in just a few moments, the spread in the models. But starting tomorrow afternoon, we expect to see some light precipitation into tomorrow evening, early evening. Now our clock's all set back. That's, 0Z is going to be 6 p.m. on Saturday evening, 0Z Sunday 6 p.m. And that precip lasts until probably at least till midnight. All right, let's go to the time height section, kind of get a sense, a flavor of what we might expect to see. And this is not as impressive as it looked earlier. A couple things that I'll point out. So again, red is relative humidity. Yellow are the potential temperature contours, or isotropes. Green is the dynamical tropopause, or at least the PV above us at this particular time, which will be very likely the dynamical tropopause that shows up. And you can see over time, we're getting this westerly wind flow. We do get a period where the relative humidity goes up, so there may be, I haven't looked outside carefully, but there may be some clouds coming in. Briefly, this evening, those westerly winds become northerly, and then actually out of the northeast throughout the day tomorrow, and they stay generally out of the north. What I find kind of disappointing, if you're going to look for even the hint of real significant precipitation, is if you look at these winds, as we go upward in the atmosphere, they're northerly and then become more northwesterly. And so that turning is cold advection, to the extent that we can say these winds are geostropic, as we're talking about today in 610. And so this would be associated with cold advection. You can see temperatures in the column are beginning to go up. You can see these isotropes have this tilt. Okay, and there's not much in the way of significant vertical motion just right over us. Right, there is some vertical motion here, but that cooling isn't accomplished with any significant vertical motion. Northerly winds are not favorable. We want to see at least a little bit of warm advection that's perhaps pushing some flow along isotropes toward our area. But we do, the column does get saturated, and so we do get precipitation, but it's in sort of maybe a weekly cold advection type regime. So we're going to get cold enough. We saw the temperature trend tomorrow afternoon is downward. We have the column getting basically saturated. We do have some ascent that's over us, particularly between 18Z, it maximizes, and then just broad ascent in the further up in the troposphere after 0Z tomorrow into 0Z Sunday. So that's where our precip occurs, and then the winds turn to the northwest, and then again with really chilly temperatures at the surface. That's at 273. So on Sunday, if you look at that, 273, that's pretty much freezing. If you mix it, that's a well-mixed layer that's at freezing for the entire day. And the high relative humidity, it's not really saturated, but with this high relative humidity, that could also mean cloud cover. It's going to struggle to get probably into the mid-30s during the day on Sunday if we get there. So it's going to feel like winter on Sunday. And then Sunday evening, the persistence of this in terms of cloudiness and things like that might play a role in keeping our temperatures not getting quite so cold. So let's look at the actual maps and see what's happening. What I want to first do is we'll just step forward every 12 hours, starting at 6 hours into the forecast. So we didn't I don't think we looked at the radar this afternoon, but if last night we had a nice period of, I guess the winds picked up and we got a period of rainfall with some showers and a little bit of some thunderstorms nearby. That weather system has passed by to our south and east. And we're in this broad cold advection. Here are our thickness contours. 540 line is well to our north. So cold air is coming in. We have a broad cyclonic circulation over us. That's going to favor some broad ascent as you get frictional convergence in the boundary layer. And so when we looked at did we look at a satellite image over us this morning? Let's take a quick look at the satellite. We would expect from this band of clouds and just a broad sort of swirl of clouds over the Midwest. I think you somewhat get that. Here's the cloudiness associated with that frontal system that passed by yesterday, and then this broad swirl of clouds is associated with a cyclonic flow and convergence in the boundary layer. And our upcoming weather event is over there in Alberta. So this is kind of an Alberta Clipper type event. Let's go back to the forecast map. Okay. And we should probably also look at a radar in a second, but over northern part of our state, some light rain or maybe rain and mixed snow showers toward north, probably warm enough for it to be liquid, and over parts of Minnesota. Let's go ahead 12 hours to 18 hours in the forecast. So this is going to be valid at midnight tonight. Again, this weather system out the east has continued to move along. And here is our Alberta Clipper type system moving southeastward with a pair of cyclones over parts of northeastern Montana and southwestern North Dakota. Again, precip's not over us. Again, it's fairly benign pattern over much of the U.S. with the exception of this area of precipitation, which is probably likely mostly snow. And light winds tonight with the pressure gradient relaxing over us. Let's go to 12 hours tomorrow morning. Tomorrow midday. And this is where the things begin to set up. Over the lakes, we have, it's not particularly cold over the lakes, but there's a forecast of some precipitation just over the Great Lakes, over Lake Michigan. But here is the weather system that we want to watch. And what's interesting about it, or what's not too particularly interesting about it, it's fairly benign in terms of its intensity, 1,011, 1,012, not really a well-organized center. Broad area precipitation. Let's go to the 850 map and look at the winds and temperatures at this time. Okay. We have perhaps some modest frontogenesis just to our south. You can see the main baroclinicity, the main horizontal temperature contrast is just to our south with a local area of warm advection that's maximized really in southeastern Iowa. Over us, there's the weak cold advection that's occurring, so there is some confluent flow, but it's really concentrated right along the border of Illinois and Wisconsin. This doesn't look from this particular forecast to be a really robust event for us. It may be cold enough to snow, but amounts aren't going to be particularly exciting. John and I were looking at this earlier in the week, and I think the peak in terms of total precipitation for us in terms of frozen precip, if you assume a 10 to 1 ratio, was like 9 inches. Yeah. And then obviously that wasn't going to happen. Would have liked it to happen, bring it on and all that, but that's just not going to happen. Okay, let's go ahead. We'll stick with this at 850. Just let's go ahead just by 6 hours. Okay. And we have just basically a trough that's passing by to our south. Warm advection looks like it's increased a little bit once this weather system has gotten just to our southeast. And even, in fact, parts of southern central Illinois, really strong warm advection that sort of fades as we go northward. So this localized airborne advection is probably going to be the focus of where most of the precip is. Now, obviously, you can't look at one map and diagnose the full vertical motion picture, but to the extent that we have baroclinicity here and airflow along isotropes moving northward, the precipitation is probably going to extend well into, at least into the southern part of our state and also through parts of Michigan and southern Lake Michigan at that point. But you can see behind it, really strong cold advection is beginning to set up across the northern plains and the western part of the Great Lakes region. Let's go ahead again. Let's go to the surface, at 36 hours. And at this point, again, the accumulated precipitation, the max accumulation is to our south, at least by this particular model. But one of the things I hope I've emphasized most times this semester is let's not look at just one model. Let's look at a sort of ensemble of predictions for around this particular time. So let's go to the pivotal site. Also, that's about 1,005 or so. So the cyclone is amplifying as it moves by. So this is for 0Z tomorrow. So this is a 36-hour forecast. And what we're going to do is, let's start with the GFS first. So these are all forecasts valid at the same time. They could be for model runs that were earlier, 12 hours earlier or 6 hours earlier, but they're all models available at this point for us to do a comparison. And here's the GFS forecast for tomorrow at 6 p.m. And this shows the cumulative precipitation over the 3 hours ending at this time. First of all, the models do have a much more intense and more vigorous cyclone. I think the WRF was about, what, 1,010 or so, 1,000. It was much higher in terms of sea level pressure. This is down to 1,004 and a fairly nice pressure gradient on the backside of that cyclone. Notice the precipitation extends just into the southern part of our state. Here in Madison, we're just on the edge of that. At least in terms of precipitation type, this is expected to be largely liquid through Chicago and maybe Rockford, but then when you get north of that, it may be just cold enough to be in the form of snow. And again, the really intense cold setting up to our north, I think, and west is something to watch. But as we slowly go across the map, we'll go to CFS. I'm not going to detail too much. CFS is the climate forecast system. That's that model that runs all the way out to 784 hours or something like that. I don't know who looks at that, but
Nobody.
right. No one that really wants to make a forecast looks at it. But in any case, it's available. It shows a cyclone there. This is this is basically the state of NWP back, I think, when we started, John, in terms of resolution of a model like this.
That's true, yeah.
Let's go to East and WF. Okay, valid at the same time. Again, I don't want to mix the variables that we're seeing here, but again, frozen and mixed precipitation over us. A nice cyclone center down in the southern part of Illinois. And again, the main precip focus is just to our south. We'll switch and look at accumulated precipitation in a moment, but let's just look at the short-term accumulation. Cold enough for snow, but very light precipitation. The Canadian model, GDPS, same time, hasn't even arrived here yet. Okay, but the western part of that being snow and a far weaker cyclone. So couple elements. We're still in cold advection, weak cold advection over us that would favor generally subsidence, particularly if it were localized, but this is sort of a moisture-starved event. The HRDPS, I think this might be a high-resolution forecast from the Canadians, and it is for the Canadians because it cuts off the southern part of our country. But it does have us in some precipitation, but again, maybe because of the model boundary, this is not a very intense cyclone. Let's go, but
It's for you, Mar-a-Lago.
Yeah.
Yep, there's no future for there. Okay, the HER. High resolution rapid refresh does show a little bit more of an intense precipitation band closer to the Wisconsin-Illinois border, but that's not, again, it's not here in Madison, so again, I'm somewhat disappointed on that. The ICON, the German model. Light precipitation, most of it focused well to our south, in fact, mostly liquid in this particular one. Actually, I'm curious if we can do this, Pete. Can we do a sounding?
Oh, that's a nice combination of temperature and dew point.
Yeah, it does say best precipitation type snow, but I guess the accumulated precipitation prior to that time was going to be liquid. Again, still shows the cold advection, but having a spread like that temperature-wise is pretty good for us in terms of being able to get some cooling to a wet bulb for frozen precipitation. But the dry air there is also another element. Some of that's going to eat up any of the precipitation that we get. Let's close that out for Pete, please. Continue our, so the MPAS model does bring the precip right up to the border. It's a bit more intense even over us. We'll look at a total accumulated precipitation in a moment. And let's quickly just drag this across to see some of the other solutions. The timing of the precipitation, when is it going to start? Again, it still looks like mid to late afternoon, and the amounts are going to be light. That's the NAM. Actually has the maximum much further to the north, and it's so many models diagnosing each of them individually. This doesn't look bad for the 3-kilometer NAM. That's a much more well-developed cyclone, but the track is not one that would get me excited in any winter situation. I'd like to see it a little bit halfway between Chicago and where it is and that to get
No,
really
thermal
excited.
winds got a little different orientation in this place too. It's a
Right.
little more to the northeast. than-
Right, so yeah, that's a great point. So
Upper
to the extent that
trough.
we have to look at the actual upper trough, but assuming that the thermal trough here is going to give us some idea of where the vortex, the 500 millibar vortex is, yeah, that thermal wind does put us down shear, but more in the southeastern part of the state, I think, to be in a favorable location. And it really isn't a narrow zone here. Well to the north of that, there's not much in the way of forcing. So, and then we look at the RAP, and then there's another Canadian model, RDPS, that just totally loses it. Rapid refresh forecast system A, not much. That'll be replaced by a MPAS system at some point. And the UK Met model, that's it. That's it. not much in the way of precip. So let's keep this option up, but let's go to the accumulated precipitation. And we're gonna look at 2 different times for winter weather, and we'll look at just 24 hours. I'll do total snowfall, because nothing's gonna happen before then anyway. Okay, as we go across, and actually we have a couple more models have entered the chat. Here's the UW-AOS AIFS, and this is valid through, lost the time, 0Z. Let's advance this one more. Just one more time. Or actually go to 6Z. This will be the total for the event. So if we go back to AIFS, and we'll do one other thing. Sorry, Pete, I'm asking you to keep doing things. Let's just zoom in. I don't want to look at the whole thing. Regional. From that. Okay. So this is the artificial intelligence model, using WF. Again, gets us up to 0.8 of an inch of frozen precipitation. Remember, the ground is relatively warm, so some of this will be lost to melting. WF model itself, it's physics-based model, 0.4. Not much to get excited about. Canadian 0.4. GFS 0.8. Yay. Okay.
Oh, 1.
Yeah, 1.7, 1.8.
Western Iowa
Rather.
is the place to be. You know,
So yeah, it's like
you
the
don't say-
cyclone kind of falls apart and then the precipitation area begins to sort of redevelop as it moves further to the east. Let's keep going. And also, this is all rainfall south of this.
Yeah.
It's not no precip, it's just rainfall. So collection of forecast, that looks pretty dismal.
Mhm.
I don't know what to make of that.
2.6.
Again. So what I gather from these, we can just quickly run across this. Let's stop at the NAM and the 3 kilometer NAM. Those looked more intense in terms of the forecast. Again, the critical thing for us is going to be the main baroclinicity, where you would expect much of any of the frontogenesis. And again, surface or the thickness contours were really concentrated down here. So the main baroclinicity was largely to our south. Any frontogenesis that's going to occur north of that would create precipitation band roughly in the region we're seeing a lot of the simulations. But I think it's just a little bit too far south if this verifies for us to get much in the way of a significant accumulation. The Weather Service does do a blend of models.
What was that one? Oh.
That's the rap. I'm not gonna rap about this storm because it's a little humor there. RDPS, RRFS, again the rapid refresh model, and then finally UK Met. But we'll look at the sort of blend of models. So they statistically combine some of the forecast output, and
They blend.
that gives us a 0.3, a dismal 0.3. So will we see snow on the ground? I think it's likely we'll see in some places slushy accumulations. I think Madison will be one of those places, but it's not going to be something that will be memorable.
Yeah.
And there is, I would say, maybe a 20% chance that we don't even see flakes of snow. It's just too dry.
Plus the wrong time of day. If you're not up at midnight, you might not see it.
But I think the temperatures are going to be dropping fairly quickly post sunset. So we have a period after 6 p.m. where the temperatures are going to drop enough, I think. In fact, if we could bring up the GFS. Oh, yeah.
Professor, for the National Weather Service blend of models, why along the Missouri River in northwest Iowa does it not really show much when so many of the models had a good band down the Missouri River?
Okay, I'm going to guess if we were to, let's go to another variable, let's go to the precip. So just liquid precip in general, and go total precip. Yeah. That may be a function of temperature. Right, so in terms of liquid precipitation, we're seeing a maximum in the band to the south here. Is this the area you're referring to?
There's so many of the different models that have like a snow band of 2, 3, 4, 5 inches along the western border of Iowa, and then on the blended models.
Okay, so it's going to be partly a function of what goes into that blend of models. Not everything we saw here is part of that blend, and I think that's probably the greater part of that.
Do you know what goes into the blend?
Can't tell you right now, but I think it's all of the US run models, European Center, UK Met, and I think some of the Canadian models. But not all models like these various versions of the MPAS. The NSSL ones might be in that, but ICON I don't believe is going to be in there. We can get a list of it, or you can do a search on that to find what goes into that blend. What was I going to look at? next, Pete, before we got to this, we were looked at the total accumulated precipitation. Let's go back to the GFS and just go to the forecast, because I want to talk just briefly about the cold surge that's coming in.
Is this the first lake effect snow event?
Yep. The other aspect of this storm, particularly once it gets past us, let's go to sea level pressure and precip. And we can just keep, let's go to 48 hours, please. So Sunday morning, cyclone is out of here, and look, you might think, oh, that's about it for this particular event. A lake effect band has set up here over parts of Lake Michigan. Again, southeast Michigan toward Detroit, probably could get a significant slushy snow event. But if we go ahead in the forecast, a significant lake effect band really sets up as the cold air really surges in. And look at these thicknesses, 516. Look, here's the band, and we just keep clicking through this. I don't think we're quite over with it. Let's keep going forward. And a lot of the models have been forecasting a small vortex to form over the southern part of Lake Michigan and then swing south and southeastward into Indiana. Keep going. And what's interesting is that it wasn't just GFS. European Center also had a very similar forecast yesterday with that. And we'll go back to the full map. This cold air is going all the way down to Florida, so they're going to be temperatures, I think, expected in the 40s down in Florida at some point. This is again a very significant cold air outbreak. But on the heels of it, almost immediately, once we get past Monday, warm advection starts up over the plains, and we're about to head back up into the 40s and maybe 50s after that. Cold air still lurks to our north. Here's another wave coming through, and it's already through us by Wednesday. So again, it's sort of a seesaw in temperatures warming up on Tuesday into Wednesday, and then cooling off again.
Yeah, it's just making me think, when we get cold air outbreaks anywhere in the U.S., it's usually a high amplitude flow.
Right.
And it's usually in the middle of the winter. In the middle of the winter, snow cover moderates the recovery time.
That's right. That's an excellent point.
Amplitude.
Right.
It doesn't yet at this time of year.
We're not going to see it. Yeah, we're not going to see that. I think it would be interesting, and we can quickly do that. I want to just I said I wasn't going to do it, but I'm going to do it. We're going to go to 384.
Yeah.
Okay. Scroll down just a little bit. You already see it. There we go. So we get a cold air outbreak. I talked last week or the week before about these cold air outbreaks kind of beginning to put a halt on tropical developments in the Gulf of Mexico, but they have to be long-lived. But they suck up a lot of the heat content at the upper part of the ocean as you get cold air over it. But there is some recovery, and it depends on how long that cold air stays out over the water. But it could be argued that if we didn't get this cold air outbreak and the ones that may follow between then and this forecast, this could be a much more intense storm because the Gulf would still have been largely untouched. But models are forecasting something in the Gulf, and that's been kind of hinted at over the last, not necessarily the 6Z run or the 0Z run, but at the last end of the week, or the last couple of models near the end of this sequence, they've been forecasting something emerging in the Gulf. We have had no Gulf storms, I think, this year, so that might still be in time for that. But I wanted to look at surface temperature and just the impact of snow cover just briefly. So John's point was a great one. If you have a large, expansive area of snow cover, that's going to have an impact on how quickly the air mass can moderate. So let's go to 48 hours. Some places are already going to just have snow. But here's the cold air coming in. That's another thing, just look at the temperatures here. But can we see evidence of where the snowfall was? So this is Sunday. Remember we said Detroit was going to perhaps be under the gun for some significant precip. It's a little bit cold. The real cold air is still back here, but notice in southeast Michigan it's cold there, but I think it's because of snow cover. Go to 72 hours, please. I guess this gets washed out pretty quickly because the ground is still warm.
Yeah.
But look at these temperatures.
12 degrees.
This is going to be just.
The stuff to the east of Chicago, that could be lake effects.
Yeah.
Oh, yeah, right.
No,
That's-
right there.
Yeah. Right there. Oh, yeah. That's gone then. Okay.
I have a question.
Yeah.
Well, two questions. The first one is, with the temperatures currently in the southeast being in the 70s, with this cold air coming in, is there, in the jet, with the high amplitude flow being sort of a, southwesterly jet, is there a chance of severe weather associated with this cold front that moves through?
That is a good question. I think it's going to be dependent on maybe the shear, and also I don't think it's particularly humid. I don't think the water vapor content's large. But let's go to SPC and just take a quick look.
Getting at some questions that John and I are thinking about.
Oh, yeah, the early encroachment, right. Because this looks like a January or February.
So we're looking at not necessarily so we're looking at beyond days 1 and 2, the current front that's going through their stuff. We're looking sort of beyond that. Is there any signal that shows up? And
A little bit on the coast there.
yeah,
Day 3.
so maybe on day 3, possibly. Just marginal at this point. But that's a good thing to watch for with the big contrast. But if we were to go back to the to pivotal and just look at the, one of the setups would be having significant water vapor. Maybe it close down. What's the dew point look like? That's surface dew point, but still, if we get, that's post front, so let's go to 48 hours.
Some in the 60s, right in that
Yeah,
module.
right here. Yeah, so that may be the big part of it, but the continent's getting dry. But again, when this really dry air sweeps out over the water, it's not just the cold air, it's dry air. That just sucks up a lot of the heat off the ocean, and so it's going to begin to cool off the Gulf over
And
time.
then my other question
Yes.
was, last week we were talking about the development of this huge bomb in the West Pacific.
Yeah.
And I was wondering if that is what led to the big ridge that is now like near the downstream drop.
I don't think so, only because I think by the 18Z run, or certainly the 0Z run, last Friday, so the subsequent runs after what we saw, the forecast, that kind of just disappeared. I haven't looked back. I know there's an intense cyclone that just moved off the northern part of the Philippines, I think this morning, and another one set up in another couple of days. I don't know if that was the same cyclone that goes into, was it the Sea of Japan, John?
Yeah.
Before it curved northward. So we're still a few days out, about a week out from when it was supposed to go up into the high latitudes, but we can check on that for next week.
Yeah.
Anyway, thank you, John. That was a really interesting look at the extratropical cyclone over near St. John's, and thanks, Pete. Thanks for the questions.